While searching for open source security and vulnerability scanners, I stumbled across govulncheck, which is a dedicated Golang vulnerability scanner. It supports two modes of operation, a static code analysis and a binary analysis. We are sticking to defaults here, so there are many or some options which can be specified. For example, this first one here that lets you use another vulnerability database, but we are sticking to defaults. We won't touch this one. We'll see it right in a moment. The only thing what we are going to check is the requirements, which is only this one. We need to satisfy this is Golang needs to be installed in version 1.18 or later. And the usage then is pretty straightforward. So we just navigate into the module's root directory and execute govulncheck with this parameter in order to have all the files and libraries scanned by govulncheck. There's some description about the messages, but this is nothing we are going to detail right now here at this point, because we'll see it in a moment in the actual output in the demo. There are some other options mentioned which are related to verbosity, which we also won't talk about right now. The only thing which is which I need to mention is govulncheck exit codes. And the exit code is always 0 when govulncheck terminates, and there are no vulnerabilities found in any of the libraries used, but is non-zero if there are vulnerabilities listed. So there are also some limitations, but as I said, it's an open source tool. It's a young project. I just want a little helper that which realizes an additional layer of security. So I'll have a good starting point during development phase. And that's it. So we are switching to the practical demo right now. Let's see how govulncheck will actually support us during our development phase, scanning and searching for vulnerabilities in libraries and so on. So I created a little project where I have a container file, a make file, and the main.go file under src, as well as the go.mod file. So we can briefly go over the container file, maybe the important one. I use a Golang Docker container base image with version 1.21.5. And I basically install Vim and copy the main.go file and the modules file and execute the go.mod tidy to download all the modules needed for my project. And finally, I execute the bin bash so I can run it interactively. And this is pretty much it. So we can build it. And afterwards, run it. See, the main.go file is inside this directory. Just for you to know, it's an application server or web server, Golang web server, which imports some standard libraries and one external library, actually, the Coraza web application firewall library. Nothing more. This is it. Maybe go also through the go mod file. You also see here what's imported and directly in this case, and what is indirectly imported or pulled. So next we are going to install the govulncheck library or binary with this command. It takes some second. And now we are able to execute the govulncheck binary as stated before. And we see already there are some vulnerabilities. And this is the brief description which was stated on the page. And we have vulnerability, continuation flood in net HTTP, so the standard library in this case. Standard library, there's the actual hint. So is present in Go version 1.21.5, but fixed in net HTTP standard library of Go in version 1.21.9. And there are the traces found. So where exactly did I use it is already displayed here at this stage. What do we have afterwards? We also have some other problems or vulnerabilities in other standard libraries which come indirectly with other libraries. And this is, for example, nexttext proto. And we have also the statement, the fixed statement, the found statement, the fixed statement. Okay. And also this one fixed in Golang in version 121.8, 121.8. Okay. It looks like we only have these vulnerabilities, 4 vulnerabilities. Great. Shows the amount. And we can just mitigate it or resolve these vulnerabilities by updating the container image tag to, what was it? I think the latest one was in the output 121.9. So with this change, everything should be resolved. Let's see. We need to build it again with this new container image version. And we also need to run. We also need to install this library again. And re-execute the binary. Oh, and no vulnerabilities found. You can also check the exit code. I forgot it before, but the exit code is 0, so it terminated successfully. We can also use the show verbose option here as promised to see some more information. Oh, okay. No vulnerabilities found. Package results. So we get some more information regarding our modules. There was another option, the -JSON option, which generates a JSON file with this information. And this is pretty much govulncheck. So let's do a quick wrap up. We are going through the advantages first. So the tool is open source and free to use. It's easy to use because we have less command line options that we can specify for this tool, and these are already suitable for different requirements. The exit codes are precious, and we have the possibility to write the output into a file. It's also easy to integrate and flexible. We can just specify a Docker file statement or statement in a Docker file, which will maybe test the code or analyze the code and terminate in the case you just specify the basic command and just tell you there's something which we need to take care of. Or we just specify or create a module for our test, build, and scan pipelines. Test, build, scan, and deploy pipelines, for example. The tool is an additional tool, or can be seen rather as an additional layer of security, which is good practice. The disadvantages or shortcomings of this tool are that it should not be used as a single security scanner or vulnerability scanner in your system, in your environment, because it has still some limitations and it's limited to Golang code, as I mentioned before. So it is just another tool which you can use in addition to other tools or security scanning systems. And therefore you should not rely only on this tool. It's rather a good helper for me or to me. The several months which I'm using it right now, it did a good job. It detected many vulnerabilities and also gave me the right fix version which I could just update, and everything worked fine for me. And it was really good support. but it still has many false positives. In this case, which I was showing a second ago or 2 seconds ago, it detected it correctly, the problems, but there are situations where it does not, or where it does detect some problems, but actually there are no problems when you deploy it or compile it actually. So this is the wrap up. Thanks for watching and hope you enjoyed it.